Hi, everyone. Marc from Atmosphere back. What a day. Many presentations. And now we've got a really exciting technology case study session, okay? Refrigeration case studies. That's actually, we've had so many great presentations for this conference that we've had to split it into two parts, today and tomorrow. Today, we've got 5 presentations, but some of these presentations have 2, even 3 speakers. So it's a juggling act, but generally speaking, we have about 15 minutes per presentation. And please, 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 if you have questions, put them in the chat box. And then I'll try and make sure that we can raise those questions at the end of each individual presentation. And then we should have time at the end where people can also ask additional questions. Okay, so first up, we've got a joint presentation between Red Bull and EPTA. So first off, we have Michael Markert. I hope I pronounced it okay. Who's head of VISIT Procurement in Red Bull. And he'll be presenting together with Davide Bargero,
Correct.
Marketing Manager, Food and Beverage from EPTA Refrigeration. So they're going to really be talking about Red Bull's roadmap to carbon neutrality in food and beverage, which is actually quite interesting because it's good to see that there's this step-by-step approach to reducing the carbon footprint generation after generation after generation of product. And I think that's a really good approach for many end users who are working with their industrial partners like EPTA and Embraco in this case. So really exciting to see how they've managed to improve the performance of the systems and reduce the CO2 footprint year after year. So please, over to you, Michael.
So I think Davide is starting with the presentation.
Yes, let me share the presentation on the screen. Let me know if you see my presentation on. Just
we do. Yep.
Okay. The full screen.
No.
No, and was moment because I was just a moment. I think I should. You don't see my screen?
No.
It's not a good. Okay.
Don't worry. There's always a technical issue. Yeah, perfect now. All good. All good.
Okay. Now here. Okay. Thanks to everybody and good afternoon. We are okay. Marc already introduced me and Michael, and we want to explain or to share with you an experience we had together with Red Bull in the years to develop and to improve and to redesign cabinets with the idea of improving the energy efficiency and all the other technical stuff to come more and more in the direction that is the matter of our discussion. I will go to the next slide, if I can move the next slide, just a moment. Explain to you, so really a roadmap to the carbon neutrality, and this is the purpose of our presentation today. But let me start. Let me leave the word to Michael before, just to introduce the idea of Red Bull about this matter.
Thank you, Davide. Really much appreciated that I'm allowed to be here today. So I think this picture is maybe explaining a bit how you know Red Bull. So we are giving wings to people and ideas, but we are not always just this the company which you see from the outside. What we are also facing, and what we are, what's really important for us, Davide, if we can go to the next slide, please. We are having our own POS range, and here especially we have our own cooler range. we are continuously trying to optimize this range, and the aim of those devices, of these products, is to put our cans in the maximum danger of being sold. So on the one hand side, it's all about branding, it's all about being loud. On the other side, it's and attractive, and on the other side, it's about being efficient, and as we are playing a really important role, I would say, in the retail business, we also aim for sustainability, or for a sustainable approach with our products. So this is what we aim for. Of course, it's safety, it's functionality, but it's also sustainability. Today we will talk about efficiency, but we will not always. So for us, sustainability is a bit more. Why coolers, and why are we doing the coolers on our own? Because we say a cold can is a sold can. So, and this is our most important asset in terms of our overall POS range. Sustainability, David, if we can go to the next slide, is or has been always been part of our DNA. We are usually not that loud on that topic, so we are not really this outgoing on sustainability approaches. But I want to give you a very quick introduction what we are doing. So on the one hand side, we try to increase the awareness of recycling the can, because aluminium is a really good product on the packaging, but on the other hand, you need to recycle it. We are doing a wall-to-wall production in order to reduce CO2, and the shape of our can is one of the perfect sizes for transport to optimize transport volume. But the most important thing, and this is why we are here today, is really our cooler range. This is where we worked on the last years always, and where we always strive for optimization together with our partners. And I hand over to Davide. He's more the expert in what have we done exactly, what was the journey, and yeah, I wish you fun and excitement for during watching the rest of the presentation.
Okay, thanks, Michael. So where we are now, we are in this journey. This is the experience that we'd like to share with you. So it's a long journey, starting from 2007 with our first open fan cooler. That is, it's one of the most common and used product in the Red Bull range, considering that we're talking about really an impulse product. So in 2007, we realized the first project with this model with technology available at the time. So we're talking about compressor for refrigerant. In 2009, we jump already to the next step. So we convert the refrigerant to the hydrocarbons, so to R290, and with all the components in line with the safety and the requirement of the R290. Consider that we need to refresh, and the market is demanding to refresh more and more often the units. In 2011, and we redesigned completely according to the new marketing strategy of Red Bull. So we come out with a completely new product, and was really a challenge, not only on the refrigeration but also on the material used for this product. And in 2017, we did another small step where we introduced a technology, the electronic controller in the machine that was at the beginning, but just with the mechanical controller, and some additional device for the energy saving. And this was in 2017. 2021, we jump, repeat, on another dimension. So a redesign complete of the unit with the different dimension, different proportion. We keep the experience of the R290 refrigerant, but we introduce for the first time the variable speed compressor with this technology of the smart drop-in developed by Emerson. The improvement on the refrigeration system, but also to the airflow, and to optimize also the condensation of the unit, The internal design, thinking also our experience in the retail, so we optimize the air curtain and also the hydraulics. And we include in the projects a lot of sensors. So now the technology allows us to put light sensor, temperature sensor. So whatever is able to manage the optimization of the units without any, let's say, human support, but the unit is completely self-adjusting. We take two slides to do some comparison also in terms of numbers. Here is the volume. You can see that from, we make a comparison between the net and gross volume. So there was a sensible improvement in terms of volume available starting from the generation 2007 and 2021. Capacity is bigger, so we grow also the capacity in terms of cans. And the footprint, we increase the capacity, but we reduce the footprint. And this is also another result, another big challenge. Last point, but not less important, is the total display area. So more visibility on the units according to the first generation. The second, that probably is more interesting for the technical people, is the specification in terms of energy. We move from the climatic class 3 to the climatic class 4. It means that a cabinet able to perform in a higher class in terms of temperature and humidity. We keep the product class, of course, because the purpose is to maintain cans and bottles and drinks inside the units. But you can see also the energy consumption, and this is impressive because from 2007 to 2021, we cut half the energy, maintaining an open front, but with increasing the number of the product to keep inside. The other two references are pure technical, where you can see that also the CO2 production is at the end half, the 50%, and also the energy efficiency index is much higher than the previous one. So just to give in 14 years there was let's say 3 generations of product on a place in the market with all the benefit we can understand together. The instrument used for this improvement is the compressor, and we have to think also all the investment and support given to us by Embraco. So you see the first generation with the 404 with the displacement and COP. The second one with R290, so we start to have a COP that's much better than before. Then we jump completely on a new generation with a variable speed, smaller compressor, 8 cc, but with the COP that is very important on that level. So the process is also in parallel of the technology available for this kind of instrument. I just want to spend some words specifically of the compressor, because the partnership with Embraco for us is extremely important. What is a variable speed compressor? Is a new instrument able to adjust the performance according to the need, to the real need, and not simply one on off. You see from this picture on top, you see on the gray area is a typical working time of the traditional compressor, and the green of the variable speed. So you can see also the number of the timing of working is completely different. In addition, the smart drop-in technology allows us to customize, highly customize the compressor itself. I mean, not only to control the parameter, but to set up the compressor through an interface with the parameter that we need specifically for that project. So we move from a controller, electronic controller, to the compressor, the parameter, and with the possibility, it's a sort of paradox by this slide, is to use also an on-off thermostat, and in a machine complex like this one. Talking about the OFC in specific, the parameters are possible. It's possible to set up the parameter through an interface, a web application provided by Embraco, where we can put all the parameters. We list 6 of them. So we have the target time, the max and minimum speed, the minimum speed step, and the other. I'm not a technical expert, so I just put on the paper what our colleague provide to us. But you can see that 6 parameters mixed together will allow us to have a very, very wide range of possible setup. So the impact is optimization on the cooling capacity, so maximize the COP, guarantee the cool down when I need it, and only when I need it. So when I stabilize the temperature inside, and I don't need too much power, the compressor is very quiet. I can avoid the bad result of the evaporator, the icing on the evaporator. And one of the points that we reach also is to keep always the compressor run in the area where is giving the best performances, and without compromising the lifetime of the compressor itself. So you can see that there is also several advantages in this technology. Going just to go to the last one, summarizing all the effort. So OFC large, we have 52% of carbon footprint, of benefit in the carbon footprint. And just in the previous generation of 4 years ago, there is an 80% of reduction. That is quite important result. Flexibility and a compressor system not influenced by the electrical, the voltage fluctuation. So if you think about Far East market, or if you think about other kind of market where one of the big enemy of the compressor was really the voltage fluctuation of the electrical power, this is also a huge benefit. Noise level reduction, so using the compressor only when I need it and not when on and off. It's also one part of the package. And the lifetime. And the lifetime is, we are expecting really a long lifetime, and a possibility to use the unit in the market for a longer, to reduce also the cost of the service, to reduce and to improve the lifetime according also to the new regulation. And this is thanks also to the cooperation with the company like Embraco that is supporting us with the most advanced solution. It's all from my side.
Okay.
In terms of this project.
Thank you, Davide, and thank you, Michael. Great presentation. We'll get questions for you probably later in the session, but I do have one quick question for you before we hand over to Emerson. It's great to see the systematic improvement generation after generation, but there's still some way to go, right? I guess you're thinking that. I'm just curious to know if the charge limit, the increased charge limit of hydrocarbon for commercial refrigeration is an opportunity for you to improve further. I don't know if you have a quick answer for that. If that's something you see as an opportunity to have more efficient systems, more efficient cooling cabinets, or not at all.
Say that for sure is a benefit. Maybe not influencing too much the small application like this one, but
beyond those small ones, are you going to think of combining maybe two instead of one? Yeah.
No, but for sure, if you think about a retail application, for example, where the power and the dimension of the product are completely different, to have the possibility to use hydrocarbon in more efficient system related to the hydrocarbon is a good solution before to jump in the transcritical or in the CO2 application that are, let's say, more complex, even if efficient, but are more complex. So if you can if you can involve in the efficiency of the hydrocarbons, also cabinet that normally we cannot be involved due to the limitation of the quantity of refrigerant, is a huge benefit for all.
Okay, thank you. I see we got a couple of questions for you, but it's great. We'll keep them for the end. Okay. So you have to stay focused. Sorry, because we have to let everyone else have their fair shot. So I've extended a little bit of time for everyone, okay? So just to relax, to give you the time to relax a little bit. So next up, we have Olivier Liegeois. I don't know if I guess that's the proper pronunciation.
That's a very good pronunciation. Thank you.
So director of marketing refrigeration for Emerson. He's been working with natural refrigerants for quite a while now, been in the industry many years. He's going to co-present with Adrian Crowther, who's the Design and Standards Manager Refrigeration for Co-op UK, a retailer in the UK. And then I believe Mike Gittoes will also from Arctic Circle, who's the OEM actually on the project, working with Emerson, will probably add some words later on. And they're going to be talking about small stores, CO2, which is one of the challenges for CO2, and all the work that they've done to really kind of step up the game on CO2, which is actually really exciting. This is a great presentation that you'll learn a lot from, and a perfect example of how the technology has evolved and is evolving continuously as the market moves towards natural refrigerants. So thank you, and over to you, Olivier.
Thank you. So let me pull the presentation here. So thank you, Marc. So it's really my pleasure today to be able to present this brand new CO2 scroll technology. So I will be the main presenter this afternoon, but Mike and Adrian will be available at the end of the session or later to answer any question that anybody might have for the OEM or the end user. So let me introduce the project that we're going to cover in this presentation. So the Co-op group, like many end user, has been shifting away from HFC to CO2. They started a while ago. They've been quite successful actually with the larger stores, but they were encountering some challenges in smaller size stores because the total cost of ownership remains quite high for those type of stores, mainly due to the capital cost at the initial, which is quite high due to the CO2 adders for that sizes. Also, there are other elements like the space limitation, which is limiting the CO2 use. The noise emission could be another one, especially in the urban environment. And, you know, CO2 with the high pressure can be sometime for the third-party location a problem. So what we did together with Arctic Circle, one of our CO2 partners, we have approached Co-op to test this new to the market CO2 technology, which is addressing all the above concern. And I think the answer was quickly a yes. So let me explain a little bit more about what's the Emerson mission with this new technology. So what we want to do, we want to bring CO2 at the next level adoption for the smaller size supermarkets. So to do that, we want to minimize the installation cost by providing a system which is less complex, which have less components. Also, you know, by bringing innovation technology with the vapor injection that I will explain more in details after, we are allowing a much simpler system design and having, in fact, two design in one. So that way we can do some system cost savings. You know, today, high efficiency is very critical because we know the energy cost is going up. And we need to do good things for the climate. So this is why we have really optimized the scroll design to this booster application. And we are using very high efficiency motor for the variable speed. And we also allow very wide modulation range. So this is helping the system efficiency. So to complete the full total cost of ownership, we want to have low maintenance cost. And we do that by having, you know, very high resilience for the system. So this is done having high standstill pressure, but also by using a smart controller to make sure that the system always operates safely. And in case of any trouble, we can anticipate that trouble. So let's let's look at the technology which is behind this. So Emerson, as a scroll technology leader, we've decided to implement it with for the CO2 transcritical. Why have we done this? Because the scroll is a continuous compression process. So this is a very good choice in terms to associate it with the vapor injection. The other good thing with the scroll technology is that we are rotating much faster than the semi-hermetic piston. So we are able to deliver more capacity per unit of volume, if you want. So that makes very compact and weight. So that's on the compressor level. Now on the system level, as I said, we wanted to simplify the cooling cycle as much as possible. So this is why with the new solution we have, we don't need parallel compression anymore. We really can decrease the number of components which are needed to be efficient even in the hot environment. So what we're doing more and more, we do it also with propane, we're doing here with the CO2, we come up with integrated solution approach. So what we do, we don't only provide just a compressor, but we provide also the drive which goes with it, the valves, the oil management system, and also the most important thing probably, the controller. So we have a dedicated controller for this booster CO2 scroll. This is really the brain of the system, because with that controller, we are able to optimize all the different components, including the dynamic vapor injection, to make sure that we hit the highest efficiency all the time. So let's go a little bit more in detail about the dynamic vapor injection. So typically on the market today, what you find is different type of system. You've got this one, which is a standard system. You know, with CO2 operating in transcritical, what is usually the challenge is to handle the flash gas from the tank. The easiest way is basically to take the gas and inject it at the suction of the compressor. This is very easy, but it's not the most efficient, especially when you go into warm climates. So this is why there is some design variant, like using parallel compression to handle that flash gas, which leads to better efficiency, but it's also increasing the cost of the system. So what we propose with our new technology solution is that we take the flash gas from the tank and we directly inject it in the compressor, in the scroll. So this is the advantage of the scroll, is that you can easily inject the vapor inside the scroll. We call it dynamic because in fact what we do, we add a check valve at the entrance of the compressor to make sure that none of the injected vapor goes back to the tank, which would lead to some penalties. So with this, we are able to do two designs into one. So talking about efficiency, we know when we use CO2, well, it's very sensitive to the ambient temperature. And we know when we go to the warm climates, the COP goes down, which requires to use more sophisticated systems. So with our solution, we can use one design to cover all the climates. Here you see the seasonal efficiency simulations that we have for 60 kilowatt medium temp load and 5 kilowatt on the low temp, which is, for example, typical from a discounter point of view. And you see that we can achieve between 4 and 8% of seasonal efficiency gain by applying the scroll technology versus the standard compression system. So if you think about it, taking a 6% energy average for an end user having around 100 stores, it could save up to 170,000 euro per year, which is quite a lot. And actually that number could even go up because when you see the price of the energy today, so who knows, it might double in a couple of years from now. So comparing to the two systems, so the basic system on the orange, these are the numbers I've just shown on the slide before. So not only we can increase the system efficiency, but we can also reduce the applied cost substantially. And when we compare to parallel compression on the green here, we will save more because we can eliminate the additional compressor while we are able to outperform the best parallel compression semi-hermetic that you can find on the market today. So the compactness is also a good argument for the scroll, because when you look at it, the footprint that you need for a scroll compressor is about 24 centimeters by 24 centimeters. When you compare it to a semi-hermetic, which is a more horizontal, you need about double of the space, if not more. Looking at the weight also, or new CO2 scroll compressor, even the transcritical, they weigh between as low as 20 kilogram up to 60 kilogram. Again, when you compare to an equivalent semi-hermetic, you need 2 or 3 times more weight to reach the same capacity. So at the end, this can translate into some retail or storage space savings for the end user. Also, it's of course easier to handle a smaller and lightweight unit, especially if you want to put it on the rooftop. So looking at noise and vibration. So this is showing where a typical medium temp 20 kilowatt, let's say, compressor would be in the 70 dBA sun power level. This is the largest model that we have. So this is quieter than any semi-hermetic piston that you can find again on the market. It's not only the sun power which matters, but it's also the perception. And there, you know, the sound spectrum, the quality is quite flat, and this is really helping the sound quality. So the good thing also of having, let's say, this continuous compression process, you have much less vibration which goes into the system. So that's also beneficial for the reliability of the booster. So what we are releasing now, because we made a public announcement 2 weeks ago, so we are releasing 3 family range, one for the medium temp application, and then 2 for the low temp application. One with a high standstill pressure up to 110 bar, and then one with a standard pressure of 45 bar. So all those models, they come with fixed and variable speed with dedicated BPM motors, which have very high efficiency and high capacity that you can reach with those. So when you combine those compressors together, you can cover actually a capacity range which goes from 20 to 100 kilowatt on the medium temp side and 5 to 50 kilowatt on the low temp. So that's basically covering from the small convenience stores up to medium supermarket sizes of about maximum probably 2,000 square meters. So here I listed the 5 key benefits of the scroll CO2 compressors. I've already covered that, so I'm not going to go through them again. You know, at Emerson, any Copeland scroll which we put on the market goes through very extensive testing. And this is absolutely the case for these new CO2 scroll compressors. So when you look at the few numbers to talk about it, so we have tested more than 300 compressors internally, which represent about 150,000 running hours cumulated before we are going to put it on the market. So it's not only performance testing, it's of course a lot of reliability tests that we have performed, but also sound, vibration, booster testing, and of course, field test with this case study. So now we are getting close to the 100 compressors that we've already shipped to customer for either lab test or field test and so on. And we're getting more and more requests with the recent announcement that we did. So as I mentioned, compressor testing is very important, but in this case, we absolutely needed also to perform system testing. So this is why we have acquired a different booster. We got them with actually with competitive product with semi-hermetic piston. So we tested it. So like this, we could see and we could benchmark where the competition was, and then we retrofitted the system with our compressors. Of course, we didn't need to add the compressor for the parallel compression. We have put our drives, our valves, we have put our controllers, and then we were able to benchmark against what we had received. This has allowed us also of course, to qualify the full solution package, because we needed to make sure that we went through some optimization process in terms of discharge pressure, injection pressures, all about the extreme case in terms of pressure and temperature that the system could reach, to make sure that it can operate safely and in an optimized way. And this has also enabled us to, to validate our simulation tool, because we've developed a simulation tool to calculate the seasonal efficiency of any booster using any technology. It could be parallel compression, it could be scroll, ejectors, whatever you want to put in it. And we have also calculated the cost of any of those systems. The good thing is that we've been able to validate those cost assumptions with some OEMs that they had made their calculations also. So that was a positive thing also. So in parallel to that, we had a dedicated team working on condensing units. So we have developed a range of units which goes from 15 kilowatt to 50 kilowatt using the exact same technology. So this is also the scroll with the DVI and the variable speed and the controller and so on. So like any condensing unit that we are putting on the market, there is a list of testing that we do, and not only performance, sound, vibrations, and so on. But in this case, we also add special care for the algorithm control for the DVI, make sure that in high ambient temperature can run. EMC compliance, this is important, of course, for the variable speed technology that we are using. And now we are happy to have the first units which are going out in the field. So back to the field test. So Co-op, they came back to us with the proposal of a store in the UK at Malmesbury. So it was a 750 square meter store. So this was a store with a 68 kilowatt medium temp load and a 10 kilowatt on the low temp. So for that, we made a compressor selection. As you can see at the bottom right picture, we had 4 medium temp compressor with injection for the medium temp side and 2 low temp compressor on the low temp side. So each of them had a variable speed one. Here you can see the injection going into the medium temp compressor. We had also all the compressors fitted with the oil management system, and we also have put our CO2 booster controller, which was communicated to the third-party BMS controller. So the commissioning actually happened exactly 2 years ago. Like any store remodeling, you have a very short time window to do it. Actually, I have to say, with the good collaboration with the 3 partners, we were able to do it. We had also a team of experts going to the site to make it happen smoothly. There was of course, some adjustments that had to be done at the beginning for the superheat, for the envelope control, the oil return, and those kind of things. But overall, all those minor challenges were fixed through the testing. The good thing also is that all the people had access to the site through the XWeb monitoring system that we have available. So our application engineer could, check if the system was running fine, if there was any need to adjust any parameter, so that we could make sure that the system would be at the best efficiency. So in conclusion, that field test has been running reliably for 2 years now. Even last year, even in the UK, there was a heat wave, and the system went pretty well, even if some systems don't like high temperature. This one had no problem with it. So now I think Co-op is looking at implementing this technology into other stores, including the heat recovery. One interesting comment that we got from several people at Co-op is that sometimes they were thinking that the system was not running because they could not hear it running, but actually it was running. So that's a positive comment. Actually, this is also something that Arctic Circle liked, the quietness. But I think what they liked also is the fact that we can really optimize the unit, the booster unit. And when you see for this type of size, we could probably go up to 600 kilo weight reduction, not only mainly in the compressor weight reduction, but also in the chassis and so on being more compact. So Arctic is also looking at implementing the technology at other end user. So on our side, we have started the field test very early in the program. Let's say earlier than what we typically do, but I think it was a very good experience because that agile testing really enable a faster development and validate the technology much faster than we would have done if we would have waited, another year before implementing. So that was about all I had to say today on this new scroll technology. So Adrian, Mike, and myself are available in case of any question from anybody.
Thank you, Olivier. Does Co-op want to add anything at this moment? Or Arctic Circle? Do Adrian or Mike want to add any comments quickly? Or
the only comment I would make is just how successful and how secret we managed to keep this project.
Yeah,
anyone in the industry got wind of what was going on until the announcement on the 16th.
Okay, so no, definitely, because no one had heard of this before. So well done, well done. You're better than Apple. I see you're using an iPad, so that's but no. Mike, do you want to add anything? You as the OEM on this?
I just want to thank Emerson and Co-op and all our partners for the project, really, for keeping it secret for so long, but also working together as one company to make sure it's delivered and it worked.
Okay, we got several questions, but I'll just maybe pick one, possibly two, and then we'll have more for the end. The one question, you've probably got a new customer, potentially a new customer here. Andreas Meyer, Teco, is asking, when will the CO2 scroll technology be available in the market?
So, what we are doing today, we are sampling a lot of compressors for lab and field tests. So we will move to the production volume, let's say, and production method and design by the beginning of next calendar year. But let's say at the moment we are busy, supplying OEMs and potentially also, of course, the end users at the end with compressor samples.
Okay. All right. So 2022 is a big year for you.
Yeah,
in this project, right?
Yeah. That will be definitely the one where we will.
Okay. So, and then a question from Colin about propane. So when is Emerson going to bring scroll compressors to the market that can deliver 50 kilowatts of medium temp cooling? At the moment, it's about 22 kilowatts. So, and he's specifically about propane here. So any feedback on that?
Yeah. So we are active in propane, of course, in the integral display case cabinets, which are smaller units, of course. But recently we have launched the largest scroll compressor that you can find on the market. Indeed, that compressor can deliver about 20 plus kilowatt. But what the people do, they use tandem or multiple compressors to cover, let's say, larger stores. So this is with indirect system, of course, because you have a too big charge to put this internal. But we're getting active into the larger capacity with.
Yeah, because that's what's missing for propane, right? The bigger ones, like for CO2 for many years, but now there are players in that market that have the CO2 solutions. And I'm guessing, I see Menno has just raised the question about, the 30 to 50 kilowatt would be ideal for HVAC and heat pump market for propane. So there's another request.
And we do also have programs in heat pumps, not only residential but also commercial to cover it with propane, and variable speed and so on.
I have a question for you, but that'll wait till the end. Okay. So next up thank you guys. Next up we have Andrea from Arneg. So Andrea's been working with CO2 for close to 20 years. That would be fair to say. Yeah. So you're an expert in your own right as well. So that's great to have this expertise on this panel. You're going to be talking specifically about refrigeration, but how to integrate also the HVAC element into this, which is a key opportunity or one key benefit of CO2 systems. So over to you, Andrea.
Okay, you see my screen now?
Yes, we see. Yep.
Okay, so that's fine. Really? So my presentation is concerning an integration of the HVAC system in a refrigeration CO2 system. Basically, as you know perfectly, you listen to this a lot of times, the new F-gas application is giving more troubles and giving more things to be taken care in the HVAC system, because you have to manage a new refrigerant, and so there are surging a lot of problems. In this trend, the application of a CO2 grants a high discharge temperature and so an efficient match with a hydronic system. This is giving you the possibility to expand the rack by giving a refrigeration system that is, let's say, enlarged of a set of compressors to grant the climate in the summertime, and also the possibility to improve and boost the heat rejection to grant also the heating in the winter time. Actually, there are several schemes on how this be done, but this is the idea of how the system is working. In winter time, you got the heat recovery that is coming from the tap water, and the heat recovery that is giving the hot water to the cassette. All this system is granted by the using of an external evaporator that can allow you to boost the heating when the temperature requires a higher heating of what the refrigeration system is producing.
Andrea?
Yep.
Sorry, do you mind putting the slides on the presentation mode? It makes it easier for people to see the screen. Yeah, that's a problem now. We're seeing the next slide. So yeah, there might be a technical issue there. So
okay, so
yeah.
Apart the, let's say, the speech, that I hope that you listen to me. This
Yes.
is the first part of the machine. I was telling you there is the hot water, the tap water recovery. You see the shower. You got the heat recovery for the cassette, and the external evaporator that grant you to have, let's say, the boost of a heat recovery during the winter time, because the system itself is not able to grant all the heating that is required by the store. This is, let's say, a general scheme, because the idea was to look at the behavior of the system and not to look how is the system designed. There are several ways to do the system like that. In the summer condition, you got basically the same thing. It means the tap water that is also required, and still some part of hot water, and the clima part where the chilled water is installed and grant the climatization of the store. This is where the store is located. And here you can see the profile of the temperature that are characteristic of the town, Verona, that is close by Garda Lake, such a good place to visit. So the system is a classical discount. You got 60 kilowatt in medium temperature, 4 kilowatt in low temperature. There was an heating required during winter time of 62 kilowatt at -2, that is the minimum temperature, and a climate required is 22.2 at the highest temperature, that is 37 degrees. The store has 1,600 square meters of surface and is located in Verona. The difference on between the heat required during the winter time and the climate required during the summertime is given basically by one parameter. This is, let's say, a no concept style of discount. So a lot of cabinets are open. So there is, let's say, a natural chilling of the ambient given by the multi-deck that are open itself. And this will also increase the requirement of heating all over the year. All over the year is also still required a part of hot water production and a small climate that is required for the kitchen and the kitchen, and the server room. So the final end is that you can see with this, that is the average minimum and maximum temperature profile that we were supposed of this town. This was the balance of the energy required by the building. The integration of the refrigeration system with the HVAC give us the possibility to have all the system together. So we put the power meter and we read a total year of energy consumption of the system. From that, we suppose what was the difference comparing to a standard system by the modeling evaluation and by the historical data that are coming from several stores that we got in our systems. And here you can see the energy consumption red, and what we supposed was the extra what was coming from the, let's say, climatization and heating required during the year. At the end, we achieve a result that the extra energy consumption was around for the 44% of the total consumption. So a total consumption on 135,000 kilowatt hours per year. In the reality, according to what we have read from the monitoring system, the temperature was slightly always different from what we have supposed. This is also because usually the supposed data are coming from the historical data, and as you perfectly know, in this period, year by year, there is a valuable increasing of the temperature that is read in every season, especially in the middle season. This has given us that comparing in blue the estimated consumption that we calculate at the beginning to have, let's say, a visibility of the store, and the consumption that was monitored by the monitoring system are slightly different, but more or less in the same line. We saw that there is an higher consumption that was clearly, as I told you, coming from the higher temperature that was in the store and in the ambient that we were not expecting. But also, okay, there is some model approximation that is more visible during the middle season, where the discrepancy in between the data, like here in April or October, are very different from what we are expecting. We think that this is given by the approximation that is given by the model that take care of an average temperature in the day, and so is not be able to profile correctly the consumption of the system itself. In this way, even starting from this data, so the estimated that we got from the integrated system and the estimated that was coming from a standard HVAC VRV system, we are able to make the comparison and see that the major part of benefit is coming especially for this kind of building and this kind of application in the period where the heating is required. This is because basically the major part of the benefit is coming because if you have to apply a heat pump in between the ambient temperature and a certain temperature, you have to evaporate 5 to 7 degrees below the ambient temperature. But in the integrated system, we are already rejecting the heat several degrees above the ambient temperature. Therefore, we have, let's say, a smaller pressure drop to compensate and a lower energy consumption. This is also given by the good appliance of a CO2 application, because due to the transcritical, the temperature profile match very well, as you see in several presentations, the temperature of the water increasing. The benefit of this kind of system at the end, we saw that there is a unit refrigeration HV system that we're using a natural gas, and so it's not applying that gas. You got the steam maintenance, and we got a great energy efficiency during the winter time. So with a comparable cost, because at the end, if you compare the system, the difference is very small, approximately 17.5 thousand euro. And the return on investment results to be just below the 2 years, using this value that is, let's say, more higher than the one that you are used to do, but more in line with the price increase that we are expecting in the next couple of years. The good benefit that is coming in the higher efficiency of the new winter time is possible to see for two reasons. The building has a good thermal insulation, but inside there are open cabinets. Therefore, there is always required a certain amount of heat in the major part of the year. And last but not least, we don't need the space. We have simply added a couple of compressors in the rack. So the space that is, let's say, wasted or used for the climatization and the other equipment is not required even more. This is my presentation. Thanks for listening.
Thank you, Andrea. Excellent presentation. I just wait and see if there are some questions. In the meantime, I'll ask you one. The integrated store, where you've got the air conditioning in addition to the refrigeration, is this the future for Arneg?
We believe that is the future, because we see that there is a clear increase of energy efficiency of all the systems, especially the part that is in the higher temperature, so the summertime. So the balance at the end will stay positive, and in the future will increase, because also for the customers to work with only one company that grant everyone gives a lot of benefits in several parts of their application and their day-by-day work.
What happens? So under 3-year ROI is excellent result, right? And I'm guessing that's only going to improve as you improve the performance and as energy prices go up.
Yeah.
So what happens if, for example, the owner of the building is different from the store? How do you handle that in an integrated way?
Basically, there is a possibility to expand the rack that is dedicated to the climatization, how much bigger that you want, and to increase the evaporator outside as well, in order to achieve the performances that you are willing to achieve. There is
no, I get it from the technology point of view, but from the actual execution of the project, because sometimes they might be different owners, you know, so there might be a challenge there in terms of making sure that they line up on the same goals if you're going to implement an integrated system.
You know, usually when there is the problem of, let's say, different owners, etc., we try to propose to use the water, because the water by the water meter and the refrigeration or heating counters can be easily counted and split the bill according to the result. To have a direct system is easier in the management, even there is a lot of problems of piping and equipment in high pressure that runs in the stores, but doesn't allow you to make the same split sharing that is possible with the water.
Okay. Okay. I've got a question from Colin, but we'll keep that till the end. It's going to be more fun for this. There's a lot of questions, so be warned, everyone. He's got a question regarding the air conditioning for you, Andrea. Okay.
Yeah.
I've got so many windows open now. Okay. Next up, we have Benjamin Tissot from Panasonic. Benjamin has spoken at Atmosphere before, actually, like many of you, but in a previous life, he spoke on behalf of Sanden. And previously to that, he worked for AHT, and he's been in the natural refrigerant space for a while now. And he's going to talk about their latest developments, Panasonic's latest CO2 condensing units in different environments across the European continent, north, south, and also in France. So over to you, Benjamin. When you hit the, if you hit the slide deck, please hit the projector icon, Benjamin,
yes,
so that we can see the full screen.
Okay, can you see my screen now?
Yeah, perfect. Thank you.
Okay, so thank you very much, and thank you also for the organization and for giving us the opportunity to speak and present. So just wanted to show you is just pure business cases in challenging environments, meaning extreme weather conditions, but also different applications, moving beyond food retail, I would say. So this is a short agenda, just to show you, to remind who we are as Panasonic. So we are a highly diversified company, as you may already know. Just wanted to show you some interesting figures, especially this one. I would say 62 billion equivalent euros in turnover, and we get over 10 billion from climate comfort and refrigeration business. So this field of application is key to our growth. We also have sound experience in terms of CO2 refrigeration. If I just focus on condensing units by just giving you some figures about installed base with the numbers of units. So far, Japan as home market plus Asia, Australia, New Zealand, we enjoy over 14,000 units installed. And since inception of the business in Europe, I would say close to 3 years ago now, we have already installed base of 900 units, and it's growing at very interesting ratios, I have to say. All the units relying on one type of compressor, exclusive technology from Panasonic, that is two-stage rotary compressor, practically meaning that if we want to get also low temperature application, it's coming from one compressor only. So all the condensing units we have, as we have an expertise in small capacities, are always built around one compressor. So today it is in Europe, at least small capacities, as you can see. We have highlighted medium temp and low temp application. So reaching up to equivalent 16 kilowatt in terms of medium temp. Just need to half just to get also in low temp. Key strength we have, sometimes very supportive just to have piping length up to 100 meters one way. So especially talking about convenience stores and city centers, when we have no choice about installation of the units, it's really supportive. One fan per unit, meaning that we can duct. This is also something that is really required by the market. And also in Japan, with the bigger units going over 10 HP, we try to have this kind of design with one fan as much as possible. Inner receivers as a standard, up to 12 liters so far. In Europe, we deliver filters. We are compatible with all regulation systems and solutions from the market. Important also is, I believe that we warranty compressor 5 years because we believe in our technology, and we can evaporate down to -45, which is really enjoyable, talking about deep freeze and blast freezing application. And last but not least, in every country where we have business, we have people working for Panasonic. So if you work in Spain, Spanish people, Sweden, Swedish people, Bulgarian people. Saying Spanish and Swedish colleagues, this is not by coincidence. This is the first business case I want to show you. If you remember, a couple of years ago, even during ATMO, we were talking about this so-called CO2 equator, saying that CO2 is perfect refrigerant only for temperate regions. We believe it's not the case, and thanks to technology, it's not the case anymore. I just wanted to drop this extreme example with Andalusia, southern part of Spain, the hottest region we can have. It's even hotter than in some African countries, by the way. So super high Andalusia, seasonal activity. It's an ice cream store, meaning highly sensitive product. Meaning also seasonal, that during wintertime, the store is shut down. So we must make sure that there is no leakage, no gas releasing when the unit is shut down. Highly sensitive product, like I said, and this is not a joke, but we measured during summertime this year, temperature going up to +52 degrees C ambient. So that was really the challenge, just to make sure that we do not face any issue, not to lose the products. So the solution was to install the small unit. Why? Because it fits to the needs. Limited footprint, super low sound level. Our technology, of course, with pressure management solution integrated into the unit already, and it must be resistant to high temperature conditions. There has been no space for adiabatic solutions. So let's say that it was just like working without a safety belt. Success factors, we wanted to monitor this installation, not only in Europe, but also to give access to engineers in Japan, where all the units are manufactured today. Relying on our two-stage rotary compressor, pressure management technologies, or return management technologies also, we have developed and we keep on improving. Local expertise, very important for us. Spanish colleagues from Panasonic working in Spain, so close to also the needs of installers. We train the installers. We wanted also to be part of this critical installation, so going on site. And we supported also in terms of design. So it's not only like selling the unit from A to B, but to make sure that we also participate to the B to C step, meaning supporting design and selection also of the toolings and different components of the installation. Super high in Spain, but also we had the, let's say, the opposite side of the coin with installation in northern part of Sweden, where we measured during wintertime, ambient going down to -36 degrees C. So in other words, it's safer to sleep inside the cold room than outside of the supermarket. Super low ambient temperature. Unit must run constantly. It's connected to cold rooms plus also to closed showcases. Extended piping length. This is why I wanted also to underline piping length going up to 100 meters. I think the farthest point has been reaching like 95 meters, if I remember correctly. And of course, no possibility to install inside. So it must be outside, facing super challenging ambient temperature. So once again, solution, it's our 10 horsepower fitting to the needs. Our technology, by the settings, pressure management or return technologies, and success factors, more or less always the same ones. We are here from A to B, but also B to C. It's training, once again. I strongly believe in this. The three major elements are number 1, training, number 2, training, number 3, training. Very important also to deploy CO2 technology from our side, but NatRef generally speaking. Support from local people as well. And what is very fine also in this kind of supermarket, that was rather big, I would say equivalent to 1,000 square meters, it is that we can deliver with condensing it step-by-step installation without shutting down the entire store, especially when you consider about store extension, like adding a new cold room or refurbishment, switching from HFC to CO2. So in terms of extreme ambient temperature, this is what I can show you, but I would like also to move beyond food retail with you, which is healthcare. Healthcare reliability is a must. We start to get more and more requests out of, I would say, our standard market of food retail application or food related applications, but more to like industrial application and healthcare. Healthcare, the real mantra is reliability. You lose food, it's a disaster, it's unacceptable. There is an issue with healthcare products, it's monstrous. You throw everything away or you can endanger people. So this is the first step, reliability, stable temperatures. No choice in terms of location of the units. Cold rooms must be able to start, I like the concept of it, refrigeration on demand. I like it as switch on. I don't need a switch off. Meaning we have to find some ways also to manage pressure when units are stopped and also when ambient temperature is rising. So in this particular case, we had selected 10 units. Why? Different application in terms of temperature, mid-temp, low-temp, first of all. Second of all, a backup. This is what we proposed, but ready to start by playing on the settings, meaning that let's consider a failure. All of a sudden, it reaches several alarm steps. Then, based on these settings, a backup must start like immediately. So, once again, it's based on our technology. It's based also on constant discussion with all stakeholders, meaning the end user plus installers, with training, once again, and also working strongly on the design of the installation. Not only like supplying the unit and say, okay, our job is done, but it's also to give constant support. So once again, training plus training plus training and support. And I believe very important is just to show that let's bring CO2 beyond food retail, beyond, let's say, some classical installation, but also what I call gray market, the one we do not suspect and the one we create by saying, by the way, have you ever considered natural refrigeration for you non-food application, industrial, healthcare, and the likes? Based on our experience, this is what I want to show. We have strong tailwinds because there is a growing acceptance of CO2 and natural refrigeration, generally speaking, as a solution that would be future-proof. There are less concerns about pressure management. You use the right tooling, this is fine. You select the right evaporators, and there are some excellent manufacturers in Europe, this is okay. Components are more and more available also. This is, it's not like the situation we were facing a couple of years ago. It's easier just to find some components. Prices are just going down, moving down, which is fine. The legal framework is more restrictive. And there are some local legislation, like in Denmark, probably you've heard about, with this new law coming into force since 1st of July this year. More and more concerns about HFCs, so-called HFOs, with these components, the impact of these refrigerants, this new, what I call RXYZ fluid coming each and every day. We do not know what the situation is about. Okay. Headwinds, still, we are the minority, of course. Lack of expertise. So training plus training plus training. This is key. Internally within our organization, but also to the stakeholders, installers, to end users. Okay, as Panasonic, we are fully open. We have training displays, training centers everywhere. The availability of components, still, the offer is still smaller than by HFCs. That's true. By some smaller stores, the price remains challenging. This we have to keep in mind. There are some resistance to the legal framework with a lot of lobbying. So there's a little bit of inertia. Illegal training in some markets, yes, it remains a problem. And once again, sorry to come on this, training and the expertise. So training plus training. And something we face in refrigeration is the scarcity of human resources. This is really also a key challenge and a growing concern, I know, by some installers. And additional information I wanted to share with you is about some studies made in the US, and especially the last one coming from California. The California Air Resources Board estimate that HFCs weigh between 4 to 5% of total greenhouse emission of the state. Consider all the noise about the aerospace and aircraft industry with 2.5%. So sooner or later, this will jump into our face. Working with Manager F and on my side by Panasonic with CO2, I sleep well at night. Any more restriction? So I don't need any pills. I just need to install CO2 and then it ensures the quality of my sleep. And this is very important. So yeah, if restrictions are just coming from F-gas or any other side, we don't mind. We are future-proof. So this is what I wanted to show you. Once again, training important. And let's try to think also beyond food retail to the other sectors. I think that's it from my side. So if you have any questions, with pleasure. Thank you very much.
Thank you, Benjamin. There's a slight time lag, so I'm guessing there will be some questions coming up, but I'll throw one at you. Great to see Panasonic active in the European market and other markets, Asia being the home base, obviously.
Absolutely.
But I'm just curious, the biotech company, it said they're mandatory natural refrigerants. Are you able to say who that was and why?
I can tell you the why. The who, hardly, I have to say, unfortunately. Okay. But why? Because they wanted to be able to maintain next year, in 5 years, and in 10 years. Installation, a life expectancy of refrigeration installation is, let's say, roughly 12 years or between 12 to 15 years. Okay, I do not know which kind of guarantee we can give in terms of availability of A2L or the other guys in 10 years, but I guarantee that in 2013, CO2 we can find, and I'm not sure that the price would be higher. That's also the deal. It will be the same also with propane. 2030, propane, ammonia, water, and glycol, no issue. You know, as a provocation, that sometimes I tell installers, you have a leakage, I pay from my own money. It's going to cost me 20 euros, and I even give you a beer. I don't mind. But with the other refrigerants, no, I don't touch this, even with gloves. I would not dare. So that was their approach. I want to be future-proof.
Okay. So it was the end user understanding that they want a clean, future-proof solution.
Absolutely. A little bit of promotion also from our side, I have to say.
Yeah, I'm sure. Yeah, no. But I mean, what's great about this session so far is that, you know, if you look at the evolution of CO2, like 10 years ago, it was all about CO2. Today is about CO2. Tomorrow will be about other natural refrigerants. Okay, just to reassure the people who are viewing this. But in the case of CO2, it was all about CO2 for the kind of like the standard store. And now, you know, we're seeing CO2 go into bigger industrial. We'll hear about that tomorrow. And the biggest challenge in the last few years has been to medium and small size stores. And here, what's interesting is that, you know, we're hearing from different players in the market coming up with different approaches. And that's exciting. It means that there's competition, which if you're an end user, you're going to be happy about, because that means you've got options, you've got choices. And you can go with whichever partner you wish. So that's great. That means that there's a healthy ecosystem to deliver on a clean future. So I want to thank Benjamin. Stay online for questions at the end, okay? Please. And then we have next up, last but not least. It's always hard when you're the last presentation, right? But but hopefully people they'll be excited to hear about what the duo Danfoss and Advancer have done in terms of basically delivering a highly efficient CO2 system for medium-sized supermarkets in Central Europe. Okay, so I'm going to hand over, I guess this is another duet or duo, with Marc from Danfoss, Marc Sever from Danfoss, and Lars Bloom from Advancer. So over to you, Marc.
Thank you, Marc. Good afternoon, good morning. I have a pleasure to present you a field study, what I did in comparison with Advancer company and also the end user EDEKA. The name of the study is CO2 ejector system performance in the medium-sized supermarket in Central Europe climate zone, full year of operation, where we will try to give you outcome of this study and what is the typical challenge when you are doing this comparison of technologies, what is the reference. So we decided to have a reference, the same store, so not comparing with some other stores where we have the same environment conditions, same installations, same people buying food all year round. So the reference is one store. Lars is here, a voice of Danfoss customer, but it's also will share a voice of end user. So at the beginning, I will give you information. I will give the word to Lars to give his view on the topic, and also after him I will continue with the let's say what we get from the system. Lars.
Thank you very much, Marc Sever. Yeah, thank you very much for having me. Unfortunately, EDEKA, which is the end user, could not join. I think it's due to the fact that Christmas is coming early this year, so they are too busy to participate, unfortunately, but I volunteered to give you a little bit of the insights. The case study or the supermarket we are talking about is in EDEKA. EDEKA, if you don't know, the supermarket chain is a German-only food retailer operating only in Germany. They are divided in 7 regions, and here we are talking about the region of the Rhine-Ruhr area, which is the west part of Germany, which is located in North Rhine-Westphalia, which has the largest population within Germany with 18 million inhabitants. A little bit of the background why EDEKA has done this and why have they went this path is that in general EDEKA wanted to get rid of classic refrigerants, and they wanted to go towards natural refrigerants. By doing this, they also wanted to get rid of fossil fuels like oil and gas. Plus, even more, they also wanted to combine heating and cooling and also the air conditioning of the store. I have to say, for us at Advancer, this is a standard solution. We are doing this many, many times a week. For this solution, what Marc is presenting a little bit more in detail later, for us it's within our cubic range, which is a highly customized platform, and it comes with advanced heat recovery. Overall, the strategy for EDEKA was to reduce their CO2 footprint. Next slide, please, Marc. Thank you very much. As I told you, EDEKA has many regions. We are talking here about a region of 900 stores. First transcritical CO2 solution was built in 2009, so a couple of years ago now. You can wonder what was before. It was Cascade, and what was that before? It was for applications. And then quite fast, EDEKA stepped into integral solutions, meaning combining the cooling and the air conditioning within their stores. This was done in 2014. By doing this, they also had to adapt a little bit of the ventilation system, They also had to think about how to heat up their store fully. So they found a floor heating system. And also there was the need that an overall BMS system was telling our WEC, for example, what to do. The air conditioning is not fully towards the store. In Germany, we don't have the need for it. So it's really only for the fresh counter area where we have air conditioning. And the heat recovery is a two-stage heat recovery where we heat up the store, and also we produce hot water for cleaning and for the butcher area. After doing this, and after fully renting into the integral solution, the next logical step was then thinking about energy efficiency. And in the first place, in 2017, they introduced parallel compression, and quite quickly, a year afterwards, it was the gas ejector introduced, and 2019 liquid ejector. And since that, this standard solution for Edeka within the medium stores. And you can wonder, what is a medium-sized store for Edeka? It's in between 1,500 square meters selling area. Next slide, please. The overall result is that obviously there was a little bit more invest, but the return on invest is within the frame. And the frame is 2 to 3 years at Edeka. The overall energy consumption could be lowered by 30% per store, which is a quite high number coming from 404A. And also Edeka could sharpen their CO2 footprint. Plus also, and this is, I think, it was keen in the past. I think nowadays it's forgiven that the transcritical CO2 can heat up the store fully. I put this in, just you can wonder. And Edeka is fully convinced of the solution, and it's happy with Danfoss and us providing these solution. And now back to you, Marc. I hope I was in the frame. I stole you 2 minutes. Sorry about this.
Thank you. It's okay. So let's talk about this particular store. Well, the name is Edeka Fausten in the area what Lars explained. So it's in a capacity-wise very similar to those systems presented by other colleagues during this session. So 70 kilowatts on medium temperature, and on a low temperature a little bit higher, it's 16 kilowatts. What is important to note once again, that there is no other heat source on the plant, and all the heat is produced by the refrigeration system, and there is a heat pump evaporator, let's say, integrated in the gas cooler. So this is very important to know, because you will see the results are linked to this way of operating the system. So what is implemented on this store? It's very simplified scheme, of course, and well, the whole story, what is today's subject, is the integration of this combi ejector. What does it mean, combi ejector in Danfoss? It means it's a combination of two different technologies of ejector. One is a high pressure gas ejector, another one is liquid ejector, all in one block. And this enables us to have a compact solution for this size of the system. And when we are talking about size of the systems, it's okay, medium to larger size of commercial refrigeration systems, but once again, with parallel compression system. Hearing some other coming technologies, I believe it will be also possible to utilize these ejectors also with other solutions coming soon. So what is all about? Having these two different kind of technologies, we can utilize ALC, superheat control on medium temperature evaporators, and what we say as a calm solution. What does it mean in reality? So we can run systems on medium temperature evaporators as a, we say, almost flooded, almost liquid mode. In that way, we can utilize surface of evaporator much better. And by doing this and some network feature, what we have in our network unit, we can increase the suction pressure. And as you can see in this example, it's -5 degrees. And typically what we notice on this real system, we can increase between 3 and 4, sometimes 4.5 kelvins comparing to the system without this operation. This benefit we are gaining all year round because the liquid ejector as a technology is designed also with at a low pressure in the gas cooler. The second technology is a gas ejector, and it is related to suck the gas from the suction line and to deliver this gas to the receiver, and actually to release consumption from the medium temperature compressor and deliver it to the parallel compressor. In this case, and this is what is very often neglected when we are talking about ejectors, this is applicable in warm weather conditions. This is very clear from all studies, but also it is valid for the heat recovery mode. Why? Because in the winter time, when we have a request for heat recovery, we are actually running almost like in a summer condition. We are increasing the pressure in the gas cooler. We are also increasing the temperature out of the gas cooler. So typically condition what is very often in the system, it's 80 bars in the winter time, and temperature out of the gas cooler 30, 32 degrees Celsius. So actually this is a summer operation in winter time. And by doing this, we have a maximum heat recovery from the system. How we did it? So again, simplified schemes. On the left side, there is a standard system with the parallel compressor, and simply the ejector block is switched off, and also the adaptive liquid control superheat was switched off. So the system was running like with the normal system with the parallel compressors. And then we switched from time to time to change the operation modes to the system when the ejector is in operation, and also the adaptive liquid control on the evaporators is active. So you can see here that the high pressure expansion valve is, let's say, checked with the yellow color. It means it is ready to run. But what we found out in the system that in all time, I mean, during the whole year, we can cover the whole motive flow coming from the gas cooler, only running with the ejector block. So there was almost no need to run with a high pressure expansion valve in a parallel. But anyway, it was here as a redundancy, or also in a previous case, it was doing this high pressure expansion. And here are results. So this is the highlights of this presentation is you can see we did measurements on each compressor. We measure electrical consumption, energy consumption, and this is in the sample rate of 15 minutes. So, and then when you summarize all this compressor consume and you put in the table with the ambient temperature, you have this cloud of data. And when you get a trend of this data, you get these very nice curves where you can see a very obvious influence on the right side when the higher temperature are getting. So the black or gray color, this is the color of operation without ejector. So it's higher consumption here, and the system with ejectors engaged, you see the trend line is of course showing that you have a savings here. Why we don't have a line extended here? Simply, okay, we didn't have conditions, we didn't match conditions using ejectors at that mode and having these higher ambient conditions. But anyway, it's very visible, the trend, how it goes. Also in the winter time, you can see here big cloud of data between 0 and 10 degrees, where you can see engagement of the heat recovery system. And especially when we engage this additional evaporator, what we have at the gas cooler. So of course the load in the system increase dramatically than looking only having system without a heat recovery. But as you can see here, we have a substantial savings in this period. On the right side are now these two curves, but let's say calculated on an hourly base. And when we have this model of the system, we just did the following comparison. The place of the store is in Grevenbroich, which is near the Düsseldorf area. And I took data for the reference year in Düsseldorf. And here you can see what is the weather profile. So here you can see the temperature, ambient temperatures, and then you can see here number of hours in the year. So you can see in this northwest part of the Germany, majority of the hours are here between 0 and 20-ish degrees. So you can imagine now how this influence on performance of ejectors and how it influence on the consumption. And when we took all this number of hours, which is 8,760 hours in the year, and you look on every month what will be consumption with or without ejectors, you can see results presented in the graphs. So you can see substantial savings in the winter time, of course, savings in the summertime, but I'm emphasizing again, this system has only source from the refrigeration. So here we are really benefiting a lot from this heat recovery unit. As a summary, so on a yearly base, we note savings approximately 90%. And when you, of course, calculate it in some euros, in this example, this value of how many cost 1 kilowatt hour for the EDEKA as a buyer of the energy, this is the value what we got from them. Of course, if it differs from country to country, users to users, this is a different number. But anyway, if you calculate these values, you will get some savings around 5,900 euros per year, which on this size of the system is a quite interesting result. And as a kind of conclusion, I would like to say that very often in ejector discussions, we are always talking about warm weather conditions. Here it's a proof of the possibility that you can use ejectors even in the what we can say mild Central Europe climate zone. With heat recovery, you will really gain a lot of savings because there are a lot of hours in the year your ejector will bring you benefit. Of course, you have to use way how to gain the maximum heat recovery of your refrigeration system, and then you can utilize your ejectors in the best way. So this is more or less conclusion from my side. Any questions? I'm really looking to answer to me or to the Lars. Marc?
Yes. Hi. Thanks, Marc. Thanks, Lars. Because of the time lag, we've got 22 minutes for questions for everyone. So I'll let people raise those questions, but we'll start maybe with the other presenters and then we'll finish off with you. Thank you, first of all, for presenting. I'm just going to go through all the questions and I'll start back at the beginning. There was a question for Red Bull and EPTA. In the US, Red Bull uses R600A. Does Red Bull use R608 in Europe? That's a pretty easy yes, no.
Yes.
Okay.
So we use both in the US and in Europe.
Okay.
R290 and R608.
Are you able to say the kind of percentages? Is it like 50-50 or you don't know?
So it depends on the model size, especially on the volume, which we need to cool down. I think that's one of the major drivers. I'm not able to say a percentage right now.
So you could assume propane will grow.
I would not say that propane is growing before usable ton. So I think it's really depending on the size and of the cabinet.
Okay. All right. Then why is it that ISO 23953? This is a technical question for Davide. Why was the ISO standard 23953 for testing, standard for testing and efficiency classification when there already exists a specific standard for bottle coolers? You're muted. Davide? Yeah. We've lost you. Oops. All right, we'll let him work out the audio issue, and then we'll come back to you, Davide. Okay. Then another question for EPTA and Red Bull. Thanks for the presentation. Just to be sure if I've understood correctly, in this fridges, are you using simple thermostat, while the intelligent part on the variable speed compressor and its drivers is on the, whilst the intelligent part is on the variable speed compressor and its drivers? Am I right? Ooh,
so we can't wait.
Davide. Okay, Davide is
back. So,
okay. Sorry, guys. All right. Well, we'll go to the next one then. One for Emerson. There was a comment to Olivier, I guess, is a comment to your new compressor, saying looks like an economizer part that we find on screw compressors. Do you wish to comment on that?
Yeah, well, we don't use an economizer. I mean, we use the injection, which goes directly into the scroll, but we take it directly from the flash tank. So we've looked also at the economizer option. It doesn't seem to give us more efficiency advantage using an economizer. It adds cost, but it could be useful in system where you need to keep the pressure in the store relatively low. There you could use an economizer. But let's say there is no in the field test that we did, there was no economizer.
Okay, thank you. Hopefully that will answer your question, Jean Cordier, who asked this question. David, are you back? No, he's still trying to connect. Then a question from Colin. And that question was addressed to, I guess, to Emerson. No. Who was it addressed to? It was addressed to Andrea, I think. Yes. Regarding air conditioning, I am interested to understand if the supermarket has an air handling unit with heat recovery. And as Colin explained earlier, he's got a variety of skill sets within Colruyt, and he says that we build our supermarkets airtight, insulate well, and then we do not need air conditioning. That's a message to the market, I guess. But the problem is rather that it gets too cold inside. You're doing too good a job there. So for heating, I totally agree that heat recovery from the cooling system is the best choice. So Andrea, do you wish to comment? Andrea from Arneg.
But basically what he writes is correct. In the store, there is external air injection with heat recovery to grant the minimum, let's say, fresh air in the store. But with a new store, with a new building, it's true that, as you see from all the evaluation, the heating part is more required internally compared to, let's say, the climatization of the other part of the system.
Okay, thank you.
You're right.
Davide, are you back? No, he keeps coming back and forth, so I don't know. We'll give him a chance. So, are there any questions between the panelists to each other? Now that you all, I mean, I can see a window with lots of faces. Are there questions that you wish to ask each other? No? Okay, so it's interesting to see that we've got different approaches to happening in the market now, and I want to go back to this question that was raised earlier about components, availability, pricing, and so forth. Would you all agree with the statement that basically the fact that we've got different companies that have track records in Europe have, whether they're using ejectors or not, whether they integrate the cooling or not, whether they have heat recovery or not, there's a lot of choice out there, right? Are we getting to a point now where it's actually going to become confusing for end users? Where, they're going to say, wait a minute, I thought CO2 was just one way, but you're hearing many different ways now, many different CO2 options out there and different ways to optimize CO2 depending on the ambient and the capacity and the needs and so forth. Do you think there's a confusion there, a potential confusion? Or is that actually a healthy situation to be in? Anyone wish to comment on that? Feel free.
Yeah, no, personally, I don't think there's a confusion. It's just like a menu, it's a la carte. There are many options in the market. So actually the purpose is, what do you need? It's not really, we have this huge variety, is okay, is to ask end users or installers, is what do you want? What do you need? And then we make the selection out of it. There are some choices in, let's say, directions taken by some manufacturers. But
sure.
Practically, the idea is to show that there is a huge variety of solutions. By the other refrigeration solutions, let's say the dying one, just to be nice.
The dirty ones.
Yeah, more or less. There is also a huge variety of solutions. So actually, NatRef is not, you have CO2 dot, you have R290, oh, it's only integrals. Forget about other applications. Once again, we are super complementary to each other. So if you want to have ejection, yes, we can. Heat recovery, yes, it's possible. So the question is just, what do you want? And then you can make your shopping out of that. And I find it healthy. If it would be limited to one technological choice, I would find it super concerning. Definitely.
Yeah. Okay. I see lots of people nodding, so that's a good thing. Yeah. So what about, that's agreement. Good. No, because it's clear. It's clear. I mean, but then if we look at Europe, Europe has led, and to a certain extent, Japan as well. Okay. But you could argue that Europe has really been a leader in the natural refrigerant revolution, okay, over the last decade. Many of you are global players.
Mm-hmm.
Are you, I'm curious, just pick an example, Emerson. Are you going to be selling that solution in the US?
I mean, yeah, that's the intent. We want to start with the Europe market because, as you say, this is where the CO2 and the natural solutions are starting with. But for sure, yeah, we want to go globally with the technology later on. Yeah, there is no reason why we would not do so.
Okay, but the solution was developed essentially for the European market to start with. Is that correct?
It's developed in Europe for the Europe market, but it's also applicable to the other regions. What you need to do, of course, you need to make the different voltages available, so that you have the right motor combination and drives. But for the rest, I mean, it's definitely suitable for any region. We have also Australia asking us, and South Africa. You know, CO2 is also growing there, so we already have requests for those regions as well.
Okay, and then I can see like Panasonic obviously spoke a lot about what they've done in Asia Pacific and the Asia Pacific region and Europe, but you could imagine that could that be a solution that could come to the US market, given that Panasonic also is active in that market? Is that even considered, discussed internally?
Yes. To draw some plans is a bit too early, but of course, and we have been asked also by some European clients about potential support in North America, generally speaking. So, like Olivier said, we need to adapt the units also to the voltage, to the local legislation as well, because sometimes the regulation is not really the same. And
yeah, but it sounds like, but you all, if I try and take a message from all of you, it's often the end user deciding this, not the regulator. You're doing it because the customer wants this. He's got a specific need and you're meeting that need with these new solutions, regardless in a way of the regulator. I mean, obviously the end user influenced by the regulator, right? But sometimes the end user goes beyond what the regulator wants.
Practically, yes. Yeah, practically, yes, because if they need it, then they can have an influence. On our side, I mean, talking about manufacturers, we adapt ourselves to the regulation. If they say unit must be in blue, okay, we paint it in blue. In green, must be in green. So fine, we adapt ourselves to the situation. But of course, just to go there, if we have support from any end user or any specific project, it's easier so to justify the investment. And once again, I'm sorry, I'm getting old, so I keep on repeating myself, but it's training. It's training again and again and again.
Training.
And it's training internally within the organizations, training to installers, distribution companies. Sometimes end users, because they say, wow, you're going to install this in my store. I want to touch it. I want to. In this industry, I think it's like seeing, touching is believing. So if you show nice documents, they will say, wow, great, but can I see it? Can I touch it? Can I dismantle? So yeah, if we have support from any end user, let's say in America, Canada, or the likes, of course, we're ready to go there. Absolutely.
Okay. All right, and then to Advancer and Danfoss, and also to Arneg after. I mean, Advancer is part of a big US group, okay, Dover, and obviously Hillphoenix, that is a well-known brand in the US and beyond the US. How many of these integrated systems are you seeing do you see much of a market in the US for your technology?
I mean, for me, I'm representing the DACH region, so Germany, Austria, and Switzerland. So, but clearly, when I see Advancer, then we are focusing on the European market in the first place, because I think also the F-gas regulation gives us plenty of advantages to work here in the first place. And as Benjamin said, I think training is also key with all the major food retailers to have this shift over towards natural refrigerant. You need training in all these supply chains. Definitely.
Sure, training is key, and we've actually got a panel about that tomorrow. But I mean, one of the reasons why Hillphoenix bought Advancer at the time was to bring that technology over to the US. So I was just thinking, I mean, you know, looking, you were all active globally. I mean, Arneg is present on multiple continents. The integrated approach, is that a way to develop new markets for you with a CO2 solution beyond Europe, or just is it only for now Europe?
Europe. This is our focus at the moment, because there are plenty of opportunities there.
Okay. All right. Andrea, do you want to give a try on that one?
If I can tell you, there are a lot of, let's say, interest in improving also in the States and in other countries Basically, also because the United States regulation is becoming more strict concerning the AC gas, and also because starting from the Nordic part, from Canada, etc., the customer are seeing a great benefit in appliance of the CO2 application. The first benefit that is the energy and the money saving. In the other opposite part, as you see, there is a big, let's say, scale up and step to be taken. That is the training of all the people. US is a huge country, and you require and the knowledge that has to be developed in that country.
Okay. Okay.
I can add something to this.
Yeah. Go ahead. Go ahead.
Well, yeah, we presented this in a nice way, but of course, reality is not so always simple, because typically you have a refrigeration company doing their job, and then you have a heating doing their job. And now we have to combine these two companies finally to touch each other, which is not so easy very often. Also, for example, having a heat recovery as a full as a main source of the heating, you are taking out of some other technologies money from their pocket. For example, district heating, they will not sell any more heating. So it's not so easy subject, we would like to have it easy, but again, agree with Benjamin, education is important so that people are not afraid of technology. They are not afraid of, at the end, losing their job. Yeah, looking forward for this, but reality is not always easy.
Okay, good point. Question to EPTA, now that David is back.
Apologize for.
Yeah, no problem, no problem. Question about your case study. Do the shown fridges need any sort of connectivity to be locally and remotely monitored, something like Bluetooth and or Wi-Fi? I think David is frozen or he's reflecting. One or the other, one of the two. We lost.
So this is an answer I can give
okay.
you.
Okay.
Yes.
Yeah.
Sorry.
Go ahead, Davide.
Is normal in the food and beverage is coming more and more important, and I think that Michael want also to share the direct experience of Red Bull in this particular matter.
So yes, our devices, or a certain amount of our devices, are connected via a customized IoT solution. So mainly for the retail business, we have them all connected.
Okay, thank you. All right, so then one last question regarding the air conditioning angle. That's the next big market to be disrupted in Europe. Sounds to me like a lot of you guys are getting more and more experience in the air conditioning side of things with natural refrigerants as an add-on to the refrigeration part. But could you imagine a situation where you also get directly into air conditioning for buildings using CO2 or propane? Is that something that you guys are thinking about internally that you can disclose or not, or it's still too early, or it's just, I'm just curious to hear, because that's the big market to take next.
Oh.
Anyone want to try on that one?
I can say that there are CO2 chillers on the market. So
yes, there are, but they're still a minority, obviously. But yeah, can we go? You know, this is the big market to take.
I would say 2 points. First one, on our side, we have made installations, but super niche market, which you can consider like aircon. Okay, but just to cool down some very specific applications with people with deep pockets. So all ready to pay a premium on top. The point will be the price, and once again, the training plus availability, I would say, of some components. It's not only, let's say, like condensing in it or the booster, but just also if you need the cassette plus the piping. So it's a different approach and different way of working. So probably it's part of the CO2 or any other natural would be part of the future, but I think it's going to take some time just to take off due to components plus training. It's also a different approach in terms of installation and maintenance. But in some niche application with existing solution, it can be addressed for sure. Yeah.
Okay, for me, I mean, I talk to a lot of people about this, a lot of the OEMs and manufacturers, and I get different points of view from everyone on the propane and CO2 and ammonia side, and even water. Yeah, and like, this reminds me of commercial refrigeration 10, 15 years ago. We're at the beginning of a new wave of innovation, and it's going to be driven in part by the next generation of the F-gas regulation. So I think that's an important point just to keep in your minds. And this will create opportunities for players like yourselves, because it's likely the disruption will come from players who've actually worked with natural refrigerants so far than from the incumbents. But okay, that's my point. I see the time and we're going to get cut off now. So before we get cut off, I just want to thank everyone for this 2-hour session at the end of the day. So I'm glad we were able to cover all the aspects. We could carry on, I guess, but we're not going to be able to. But I hope you've enjoyed the day, and then that you'll come back tomorrow for more presentations. So please, if you're all in your different rooms or offices, please give a round of applause to all the speakers. It's so weird doing this online. I much prefer the real thing, but okay, that's just the way it is. Yeah, so thank you, everyone. And thank you to the panelists. Great case studies. And what we can clearly see is that there's a lot of innovation happening, and we've only really just started. You know, there's a long way to go still, but it's exciting to see how things are developing so fast. So thank you, and see you for the conclusion.